All right, you are welcome again. Today, let's consider multiple integral. Without wasting much of our time, let's take a look at this question. Find the exact value of the triple integral over the range 0 to pi all over 2 and over the range 0 to 4 cos z and over the range 0 to square root of 16 minus y squared of 3y dx dy dz. Okay, so here we have triple or multiple integral. Okay, please pay attention. Let's take this integral gradually. Okay, it's very simple. Please pay attention. In this place, we have three integral. You get it right? We are going to take it part by part. The inner part, the middle, and the outer part. The first one, we're going to take the inner part, which is with respect to x. Okay? So the inner part, which is with respect to x, is the integral over the region 0 to square root of 16 minus y squared 3y dx. So this is what we are going to integrate with respect to x, and then plug in the upper limit minus the lower limit. Okay, now when we integrate 3y with respect to x, that means we treat y as a constant, then introduce x. So the integral of 3y with respect to x is going to give us 3xy. Okay, so here, that means we're going to have the integral of 0 to pi all over 2 and the integral from 0 to 4 cos z, 3xy, then the boundary or the limit 0 to square root of 16 minus y squared, we have dy dz. We just integrated the inner part with respect to x. Okay, so after this, let's plug in the upper limit minus the lower limit. So we see that if we plug in the lower limit, it's going to give us 0. Is that true? So that means we are not going to bother ourselves with the lower limit. We're just going to plug in the upper limit. Okay, since the lower limit is 0. Okay, now let's go. Plugging in the upper limit, you are going to have the integral from 0 to pi all over 2 and the integral from 0 to 4 cos z. We have 3. In place of x, we're going to replace it with 16 minus y in bracket raised to power 1 all over 2. You know, this square root of 16 minus y squared is the same as 16 minus y squared in bracket raised to power 1 all over 2. Is that true? Yes. Now here we have y dy dz. Okay, good. Now let's go. You know, here we have the integral from 0 to pi all over 2 and the integral from 0 to 4 cos z, 3y, open bracket, 16 minus y squared, close bracket, raised to power 1 all over 2. We have dy dz. Okay, so this integral have now reduced to double now, right? Good. So in this case, you also have the inner part and the outer part. Let's go further again and integrate the inner part again, which is with respect to y. Okay, now that means we're going to integrate 3 open bracket 16 minus y squared close bracket raised to power 1 all over 2y dy. Okay, so this is the inner part that we're going to integrate. Okay, now we're going to make use of u substitution. Okay, so here we're going to say let u equal to 16 minus y squared. So in place of this 16 minus y squared, we're going to replace it with the letter u. But before then, let's differentiate this u with respect to y. That means we're going to say du dy. So when we differentiate this u with respect to y, it's going to give us minus 2 y. Here we say that du all over dy is equal to minus 2y. All right, good. Now, let's cross multiply. When we cross multiply, we're going to say that du is equal to minus 2y dy. And then in this place, in this integral that we want to evaluate, which is the integral of 3 open bracket 16 minus y squared close bracket raised to power 1 over 2y dy. We want to make y dy the subject. That means we divide both sides by minus 2. So when we divide both sides by minus 2, we are going to see that y dy will stand alone. That means we say y dy is equal to minus 1 over 2 du. Now let's go. In this integral where we have 3 open bracket 16 minus y squared in bracket 1 over 2y dy. And then we say let this 16 minus y squared be called the letter u. So that means here we're going to have the integral of 3 u raised to power 1 over 2 times minus 1 over 2 du. In place of this y dy, we replace it with minus 1 over 2 du. Now let's take this 3 behind the integral sign because it's a constant. Okay, good. Now let's integrate. Here, before we integrate, let's take this minus 1 over 2 behind the integral sign. That means it's going to multiply 3. So going outside, it's going to give you minus 3 all over 2. Okay, now let's integrate u raised to power 1 all over 2. When we integrate, we're going to have u raised to power 1 all over 2 plus 1 all over 1 all over 2 plus 1. All right, good. So when we say 1 all over 2 plus 1 is the same as 3 all over 2, then we have all over 3 all over 2. Okay, so here we have minus 3 all over 2 open bracket. This u raised to power 3 all over 2 all over 3 all over 2 is the same as 2 all over 3 multiplied by u raised to power 3 all over 2. So this 2 all over 3 inside the bracket, we multiply 3 all over 2 outside the bracket. That means it's going to give you 1. Okay, good. That means we're going to be left with minus u raised to power 3 all over 2. Hello. So when we integrate, we have minus u raised to power 3 all over 2. But you see that 16 minus y squared is equal to u, right? Good. Let's replace it. That means we're going to have minus open bracket 16 minus y squared close the bracket raised to power 3 all over 2. You got it right? Good. And then here, we have the integral from 0 to pi all over 2 and the integral from 0 to 4 cos z 3y open bracket 16 minus y squared close the bracket raised to power 1 over 2 dy dz. And we evaluated the inner integral and it gives us minus 16 minus y squared a bracket raised to power 3 all over 2. Okay, so as we evaluated the inner integral, that means we are going to be left with the outer integral, right? Good. So here, that means we're going to have the integral from 0 to pi all over 2 minus open bracket 16 minus y squared close the bracket raised to power 3 all over 2, and then the limit from 0 to 4 cos z. We have the z. All right, good. We integrated with respect to y. So anywhere we see y, we're going to replace it with the upper limit minus the lower limit. Okay, good. That means here we're going to have the integral from 0 to pi all over 2 open bracket minus, we have open bracket again 16 minus, in place of y we say 4 cos z, and then we have squared close bracket raised to power 3 all over 2 minus the lower limit. Now we have 16 minus, in place of y we have 0 squared close the bracket raised to power 3 all over 2 all in bracket dz. All right, good. Now let's go. In this place where we have 4 cos z squared, let's open the bracket. If you open the bracket, the square is going to be distributed to the content of the bracket. That means we're going to have 4 squared cos squared z. 4 squared is 16. So here we have 16 minus 16 cos squared z, all in bracket, raised to power 3 all over 2, minus, when we say 0 squared is 0, then we have 16 minus 0 is 16, and then we have raised to power 3 all over 2. Is that clear? Good. In this first bracket, we have 16 minus 16 cos squared z. Let's factor out 16. That means we're going to have minus 16, open bracket, 1 minus cos squared z, in bracket, raised to power 3 all over 2. Okay? Then when we say 16 raised to power 3 all over 2, what will it give us? It's going to give us 64. All right? Good. Now, you remember the trigonometric identity where we say that sine squared x plus cos squared x is equal to 1. Okay? Now, when you make sine squared x the subject, that means we're going to say that sine squared x is equal to 1 minus cos squared x. But in this case, we have z. Okay, so it's the same thing. So in place of this 1 minus cos squared z, we'll replace it with sine squared z. All right, good. In this place where we have sine squared z, in bracket, raised to power 3 all over 2. When you say sine squared z raised to power 3 all over 2, what is it going to give you? It's going to give us sine cube z. Hello. When you say sine squared z raised to power 3 all over 2, it's going to give you sine cube z. All right? Good. Now, that means here we have the integral from 0 to pi all over 2, open bracket, minus 64, sine cube z, in bracket, minus 64, close bracket, dz. In this case now, let's factor out minus 64. When we factor out minus 64, we are going to have the integral from 0 to pi all over 2, open bracket, minus 64, open another bracket, sine cube z plus 1. Hello. We're going to have sine cube z plus 1. When you say minus 64 times sine cube z, it's going to give you minus 64 sine cube z. And then we'll say minus 64 times plus 1. It's going to give you minus 64. Okay? All right. Now let's go from this place. When we have sine cube z, it's still the same thing as saying sine squared z times sine z plus 1. Hello. When you have sine cube z, it's the same as sine squared z times sine z. All right? Good. Now, what if we replace sine squared z with 1 minus cos squared z? You know, it's still the same thing in trigonometric identity. All right? Where we say that sine squared z plus cos squared z, or sine squared x plus cos squared x, is equal to 1, making sine squared x the subject. We have 1 minus cos squared x. Okay, so in place of this sine squared z, we are going to replace it with 1 minus cos squared z. All right, good. So here we're going to have the integral from 0 to pi all over 2, open bracket, minus 64, 1 minus cos squared z times sine z plus 1. Okay, good. Now let's go. Let's use this sine z to open the bracket. That means we're going to have the integral from 0 to pi all over 2, open bracket, minus 64, open another bracket, sine z minus sine z cos squared z plus 1. All right, so here we have the integral from 0 to pi all over 2 minus 64 sine z minus sine z cos squared z plus 1. We have dz, right? Good. Now look at it. Let's also use this minus 64 to open the bracket again. All right, now that means we're going to have the integral from 0 to pi all over 2 minus 64 sine z plus 64 sine z cos square z minus 64, all in bracket dz. Alright, good. Now let's integrate finally with respect to z, but we're going to do it part by part. Okay, but let's first of all pick this 64 sine z cos square z and integrate. So that means we're going to have the integral of 64 sine z cos square z dz. So we're going to integrate this using integration by parts. Okay, so integration by part. So first of all, we'll take this 64 behind the integral sign. Okay, now in this place, we're going to say let u equal to cos square z. Integration by part. Okay, so we're going to say let u be called the letter cos squared z. Now we differentiate this u with respect to z. That means we have du dz is going to give us minus 2 cos z sine z. Let's make du the subject. That means we're going to cross multiply. Then when we cross multiply, we're going to have du is equal to minus 2 cos z sine z dz. All right, you know, after when we have identified our u, every other thing is going to give us our dv. Okay, so that means after when we say that cos square z is our u, then the remaining thing again there is sine z dz. I'm going to say that sine z dz is our dv. Now let's integrate both sides. That means we're going to have the integral of dv is equal to the integral of sine z dz. Now when we integrate the left hand side, it's going to give us v. The integral of the right hand side is going to give us minus cos z. All right, good. So here we have that u is equal to cos squared z, and then v is minus cos z. Du is minus 2 cos z sine z dz, and dv is sine z. Then integration by part, the formula says that the integral of dv is equal to uv minus the integral of v du. And then we have splitted this function that we have, and we know all these variables. We know our u, v, du, and dv. Okay, now let's bring it together. So after bringing it together, we have the integral of cos square z sine z equal to cos square z times minus cos z minus the integral of minus cos z times minus 2 cos z sine z dz. All right, good. Now let's go. Here we have the integral of cos square z sine z equal to, when you say cos squared z times minus cos z, is going to give you minus cos cube z. All right, good. Then we have minus in the other side, we will have minus cos z times minus 2 cos z sine z. Here we're going to have minus times minus is going to give us plus, and then we will say cos z times cos z sine z is going to give us 2 cos squared z sine z. All right, yes, and then we have dz. You get it right? Good. Now we can take this 2 behind the integral sign. When we take it behind the integral sign, that means we're going to have 2 integral of cos square z sine z. Is that true? Yes. So here we discovered that what we have at the second part of this right hand side is the same, or is almost the same with what we have in the left hand side. So let's take this 2 integral of cos square z sine z to the other side, or to the left hand side. So taking it to the left hand side, you know, we have minus 2 integral of cos square z sine square z. So crossing the sign of inequality, it will change to positive. Okay, you are going to have the integral of cos square z sine z. Here we're going to have plus 2 the integral of cos square z sine z equal to minus cos cube z. So here when we say the integral of cos square z sine z plus 2 of the integral of cos square z sine z, add this together, it's going to give you 3 integral of cos square z sine z equal to minus cos cube z. You know, we are looking for the integral of cos squared z sine z, not 3 integral of cos squared z sine z. That means we're going to divide both sides by 3. So when we divide both sides by 3, we're going to see that we have the integral of cos squared z sine z is equal to minus 1 over 3 cos cube z. And then we discover that we have 64 the integral of cos squared z sine z dz, right? So here it gives us 64 open bracket minus 1 over 3 cos cube z, which is the same as minus 64 all over 3 cos cube z. All right, yes. Now let's go. You know, in the last part of the integral that we want to evaluate, where we have the integral from 0 to pi all over 2 minus 64 sine z plus 64 sine z cos square z minus 64 all in bracket dz. When we integrate minus 64 sine z, it's going to give us 64 cos z. And when we integrate 64 sine z cos square z, we just did, it's giving us minus 64 all over 3 cos cube z. When we integrate minus 64 with respect to the z, it's giving us minus 64 z. And then we put in bracket over the limit, the lower limit 0 to the upper limit pi all over 2. All right, good. Here we're going to plug in the upper limit minus the lower limit. So when we do so, we're going to have 64 cos. In place of z, we replace it with the upper limit, which is pi all over 2 minus, we have 64 all over 3 cos. In place of, we have cos cube. In place of z, we replace with the upper limit also pi all over 2 minus 64 pi all over 2 in bracket minus the lower limit. Now we have 64 cos 0 minus 64 all over 3 cos cube 0 minus 64 times 0. All right, good. Now when you say cos pi all over 2 is going to give you 0, then 0 times 64 is 0. And then when you say cos cube pi all over 2, it's going to give you 0. And then 0 times 64 all over 3 is 0. And then when you say 64 times pi all over 2, it's going to give you 32 pi. So in the first bracket, we have 0 minus 0 minus 32 pi. Okay, now let's go to the other bracket. In the other bracket, we have cos 0. Cos 0 is 1. So 1 times 64, we have 64. And then in the other side, we have cos cube 0. Cos cube 0 is 1. 1 times 64 all over 3. We have 64 all over 3. All right, good. And then the other one, we have 64 times 0, which is equal to 0. So in the second bracket, we have 64 minus 64 all over 3. All right, good. Now when you say 64 minus 64 all over 3, it's going to give us 128 all over 3. All right, good. And then when you say 0 minus 0 minus 32 pi, it's going to give us minus 32 pi. So here we have minus 32 pi minus 128 all over 3. So here we have minus 32 pi minus 128 all over 3. So the exact value of the triple integral from 0 to pi all over 2, 0 to 4 cos z, 0 to square root of 16 minus y squared of 3y dx dy dz is giving us minus 32 pi minus 128 all over 3. All right? Yes. Thank you very much for watching. Please, if you are new to our YouTube channel, please subscribe, like, share our videos. All right? Yes. Let's take more examples. Stay blessed.